All right, let's go over the lab number one. And you can watch the video, but technically you don't have to do it. I'll show you why in a minute. But let's do it once. Unfortunately, you don't see the device that is being used to charge the balloons. And that confuses students. And we have to assume that always the device is used to charge the balloons is the same. And what's happening now does not matter. What matters is only the equilibrium state when these strings do not act on the balloons anymore. And on each balloon, all we have is three forces: gravity, tension, and Coulomb's force. And we can change the charge. We can do it right now. And we don't have to watch the video again. We can just jump directly to the very last frame, and done. We can use the tool to measure the angles and to analyze, to understand what's happening. Everyone should have used the everybody diagram, PY211 material, mechanics, because mechanics tells us how the angle is related to the magnitude of force of gravity and magnitude of Coulomb's force acting on the balloon. And this equation for the tension does not depend directly on the charge, just force number one, force number two. And we need to make an assumption that balloons have the same mass, or there would be no symmetry. And if we will change a charge on one balloon or on both balloons, doesn't matter, that affects the strength, the force. And let's say we make the charge stronger, so the force acting on each charge will become stronger, equally stronger, because the force acting between these two objects obeys the Newton's third law. No matter what's happening, these two forces must have the same magnitude in opposite direction. Again, PY211 mechanics. And if the force becomes stronger, repulsion becomes stronger, and that should make this angle larger. However, if the angle increases, the distance between the balloons also increases, and that should make this force weaker. So we've got two competing mechanisms, which makes this problem actually not trivial. However, if we watch the movie, the video, and we can see that the change in the angle is not very large, visible, but not very large, and the change in the distance it is practically untraceable. So we can neglect how distance changes. And in that case, stronger charge makes stronger force, makes larger angle. Well, that's it. Now we just have to choose correct answers. What's wrong with the first answer? Well, same kind means same polarity, plus and plus, minus and minus. And that means they have to repel each other. So, wrong. Because they have opposite, they attract. Well, this is the correct statement, but it is not what's happening in the situation. So, technically, you could have chosen this as correct in general. But on the other hand, that's not what the author wants you to choose. The author wants you to choose these two answers. Why? Because, again, you saw the electrophorus, kinda, and you should have made an assumption that same electrophorus means same polarity. But of course, the most natural answer is you observe the repulsion, so they must have the same polarity, same kind. Now, you can see that the deflection on the left and the deflection on the right is practically the same. And this statement is not very clear. Some students have troubles. Symmetrical. What does that mean? Well, this word symmetrical literally means that these two forces on the left and on the right must point opposite to each other and must have the same strength, the same magnitude. If you say it like that, of course, in that case, it's obvious. And the second statement is actually partially right, partially wrong, because initially you are told to watch only the first video when you have only one charge on the left and only one charge on the right. And for that situation, technically, you could say yes, same charge. So there is some ambiguity here. All right, moving on. I will do it based on the answers above. Make a prediction. If one of the balloons had more electric charge, okay. If one of the balloons had more electric charge, that would make the force stronger, but force acting on each charge equally stronger. So this angle would equally be increasing by the same amount. And then you play with the video like we did, and you can see that the deflection on the left and deflection on the right is always practically the same. So if we make the charge stronger, the force becomes stronger than before, but the force becomes equally strong for both charges. And this is what you should write. When you write your answers, you should say something about both situations. Changing charge affects the strength, and you can compare the force before and after, but it affects equally charges on the left and on the right. So the deflection will be always the same on the left and on the right. And well, the amount of electric force depends on the amount of charge. That is correct. Adding charge to a balloon, make it stronger, increases force. If the one balloon has more electric charge, that causes a greater electric force on only one. That's wrong, because Newton's third law says the force should change equally for both. If one of the balloons has more electric charge, greater electric force only on itself. No, these are basically same options. If one of the balloons has more electric charge, greater electric force on both balloons. Yes, greater, but even more, equally greater. Yeah, it's not just you make one arrow longer and another even more longer. No. So now Jorge or Jorg says, and what he says is correct. All his statements are correct. Always deflect away by the same amount. Force has the same magnitude, and the force on each balloon is always the same. Bryce says, now this is a little bit trickier. When the amount of charge added, the amount of deflection is increased. Correct. That shows that the amount of force depends on the amount of charge. And now the statement should just be stopped. That's what it says. That's what the law says. The amount of force depends on the amount of charge, period. Added, subtracted, doesn't make much difference anymore. Now, if the right balloon has more charge than the left balloon, it must apply greater force than the left balloon. Well, before or after? This statement may have a couple of interpretations. Should we compare the change before the charge was added and after? Or should we compare after two forces? And if before and after, adding charge increases force. If we should compare two forces after, well, they will be identical in magnitude. So this is what you should say. And finally, of course, it's not just you may have heard, you must have learned the Newton's third law. And now let's see, if the left balloon exerts a force, blah, 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 blah. What's wrong with this? It says only if they have the same amount of charge. This last part makes this statement wrong, because it's not just only when charges are equal. This statement is correct for any combination of charges, just this Coulomb's law. See, the Coulomb's law tells you the magnitude of the force between the charges, which is magnitude of the force acting on first charge from second, and also the magnitude of a force acting on the second charge from the first. So this expression has no relationship to only charge number one or only charge number two. And well, now you're done.